end up with the final sprints. I have one session followed by John to talk about the electric motorcycle session. Okay, all right. So yeah, my session for this now is I switch over to analog side. Okay, it's our overview of TI's sensing products. Now, by now you should know that TI, we have almost everything. Okay, remember, some companies come to you and they tell you that, oh, they have the best processor or microcontroller. Some come to you, they say that they have data converter or amplifiers, right? And some come to you with isolation, or some come to you with power. TI will come to you with everything. Okay, we can complete your design with almost everything TI parts, except for the passives, some discretes, or connectors and things like that. So we can come to you with the full ecosystem for your solution. Okay, and which is why TI we also have a lot of reference designs. In our reference design, we use a lot of TI parts to come up with a complete reference for you. So you can use a lot of TI parts in your project to get things to work. Okay, and also Aziz talked about the logic, Okay, so but one area that many customers forget TI have, or many do not know that TI have, okay, is sensors. Okay, so sensors, we have temperature sensor, current sensor, humidity sensor. Okay, we have a magnetic sensor as well. We also have radar. Okay, radar is also a form of sensor. And we have some specialty sensors like inductive sensor, capacitive sensor. Okay, so these are a range of products that TI has. So let me focus a bit more on sensors. In case you have never used TI sensor products before, let me go into the details of it. We group them into three main categories. First one is current sensor. Okay, so like current shunt monitors, Hall effect current sensors. Second one is temperature and environmental sensors. So we know there's a lot of temperature sensor on the board. Digital temperature sensor, analog temperature sensor. Okay, we also have humidity sensor or pressure sensor. And now TI also have light sensor, ambient light sensor. So for example, your LCD screen, right? If the room is very bright, you turn your LCD screen brighter. The room is very dark, you go dimmer. So that's the ambient light sensor. We also have proximity sensing. And the third pillar is position sensing. Okay, so you can do a magnetic for on-off switches, single axis, multi-axis, and also the angle at which the magnet is coming towards you. And our specialty sensor like inductive and ultrasonic. So TI, we have many areas of innovation in terms of our current sensing. Just want to highlight a few key points. First one is accuracy. So when we talk about current sensor accuracy, we're talking about plus minus 0.5%. Okay, on the last line, plus minus 0.5% over lifetime drift. Now it's easy to buy an accurate current sensor that works on the day one, but after being deployed in the field for 10 years, how accurate is it? Okay, our lifetime drift is plus minus 0.5%. Okay. Moving to the middle one, EZShunt Technology. We have an innovative technology, which I will explain more in later slides. We use our lead frame as our shunt. So you don't need to put the external resistor as a shunt. The lead frame itself is the shunt. With that, we make it small size and make it able to carry current of up to 75 amps. Okay. And as the voltages go higher and higher, we can also support 1.3 kilovolts working voltages. Okay, and also make it small size. So we are the smallest current sense amplifiers in SOT 23 package or SC70. Okay, so with these areas of innovation, TI continues to deliver new ways to do current sensing with our new packaging technology, new size, new features, new accuracy. Now, talk about one very innovative thing, magnetic current sensor, MCS, in package. So you look at the diagram very interestingly. Okay, the current flows through from these two pins on the lead frame, goes through, we do a loop, and it goes out. Okay, so your current is a bypass flowing through this lead frame. There's an electrical isolation between them, okay, to the other side, to the low voltage side. And we mount our IC chip on top of this loop, okay. Now when you put a current through a loop, it creates a magnetic field. We put our Hall sensor sitting right on top of that to measure the magnetic field. And we get a magnetic current sensor. Okay, so this involves various technologies, including our lead frame design, the way we make it high accuracy lead frame, to get that magnetic field
and we put our magnetic sensor on top of it, and we get isolation. Okay, so this is a series of products from TI called the magnetic current sensors. Okay, so to remember, it's very easy. It's called TI magnetic current sensor, TMCS. Okay, so we have functional isolation, basic isolation in a SOIC 8 package to measure up to 30 amps. Okay, you need more. We have the TMCS 1123 to measure up to 80 amps. Okay, with our reinforced isolation in a SOIC 16 package. So you can see from the package design, you can see the lead frames are very thick. Okay, it's to handle the high amount of current, 80 amps. And we have a new product just launched, TMCS 1143 for 125 amps. Okay, so with that we can actually support current sensing through a magnetic current sensing technology for up to 125 amps with reinforced isolation. And why is the roadmap like quite blank at the end? Because I can't tell you yet, but we're definitely going for higher current. Okay, we have new products coming up with higher current ratings. Okay. Now switch to lower current ratings, current sensors, is our EZShunt technology. Now, normally when you do a current sensor, right, we have a very nice IC chip from TI, INA234, very small, right, 6.24 millimeter. Sorry, it's smaller than that, okay, but a very small IC from TI. But then you have to put a 1206 resistor, 2 milliohm 1206 resistor. That's so big, taking up so much space on your PCB, and then expensive, right? You have to get a high accuracy resistor as your shunt. Now we integrate it into our IC now. The INA700, that in that 1.6 millimeter square, is the entire current sensor, including the shunt. So you look at the technology we have is that we use the lead frame as the shunt resistor. Because we can manufacture lead frames that are so accurate, okay, they can have it exactly in the range of 2 milliohms, and that becomes the lead frame shunt, and we're measuring the current across it. Okay, and one thing we know that copper, right, there's a drift over temperature. So what we do is we build in active calibration so that we can compensate for the drift across temperature in this package. All right, so we can have 15 amps in a wafer chip scale package. Okay, 1.2 by 1.3 mm, as tiny as that. In QFN package, up to 4 by 5 mm, we can do 35 amps. And if you want up to 75 amps, okay, for the shunt technology for current sensing, in a 6 by 6 package. So we use the lead frame to be your shunt resistor to do a current sensing. So with that, we make the IC chip very, very small. And with that, it's also lower cost than having to buy the external resistor. Okay, and talk about the normal current sensors, okay, that you usually have. Just want to show in one summary page, we have different package options, SC70, SOT23, and QFN packages. We have even a leaded package, we have the smallest one, okay, 1.6 by 1.6 mm. You want a wafer chip scale package, we also have, okay, 4 ball to 12 ball BGA package. These are the parts numbers listed here. And you want EZShunt, where the integrated shunt solution, we also have this solution. All right, so TI, we offer you a very broad spectrum of current sensors. Whatever current rating you have, whatever size you need, how much integration level you need, we have a large variety for you to choose from. Okay. And so, yeah, this is I'll call this an evolution roadmap of how current sensing has evolved. Right, at the start, if you remember in the early days you design, you have a shunt, op-amp, resistor, ADC to do current sensing. Okay, then we move to the next step. We integrate the resistor, become an INA, right, instrumentation amplifier. So shunt, INA, and ADC. Then we think that's still not good enough. We integrate the INA plus the ADC together, right? So become a shunt plus integrated solution. And now, we just give you one chip to do everything. So you can see the semiconductor industry, TI, we move very fast, right, to integrate, make it smaller, make it cheaper, make it better. Now, how about you? Are you catching up with us? Time to catch up with us, all right? Start to use the INA 700. Put it in your design, use the latest technology, and make sure that you have the best cost, performance, efficiency on your solution, okay? Don't use the old design anymore. All right. Okay, so that's it for the current sensing part. I'll move on over to the second pillar, which is our temperature and humidity sensors. Okay. Now, temperature sensors, first thing is accuracy. Okay. How accurate can temperature sensor be right now? We can be as accurate as 0.08 degrees. Okay. Now, is accuracy important? You talk about server power. If your error is 5%, which means that you are operating only 95% max efficiency. Okay. So in the same way, if you are 1% accurate, you're only operating to 99% of your design capability. So by improving the accuracy, okay, you can actually bring your product performance to the edge, okay, with little margin for error. Okay, and you also can be using it to sense other things like body temperature on the human or on the animals. Yeah, so temperature sensing can be done on a lot of applications, not just for equipment. We are also making it small size, okay, for various reasons. First thing is that to have accurate sensing of the temperature across your product, you need to put many temperature sensors across your whole product. So if it's big, then your whole product becomes bigger, right? So we have to make it small for you. And of course, the other reason is that the smaller it is, the cheaper it is. Okay, less metal, less lead frame is cheaper. Right, so we have PicoStar package, we have our X2 Zone package for your small size options. And nowadays, because of high voltage application, like EV charging, instrumentation, machines, you want to have isolation, but then you want to do temperature sensor. Then very troublesome, right? You need to buy isolator, then you do temperature sensor. Simply just buy an isolated temperature sensor from TI. Then you can put it across the isolation barrier and sense temperature on the other side. Okay? And we also do low power consumption. Okay? Because in the past, maybe you do 4 channel of temperature sensor. Now you want to do like 30 or 40 channels of ADC for temperature sensor. Then that will cost you a lot of power, right? So we make it low power so they can put more temperature sensors across your entire PCBA. Okay, so in summary, the kind of temperature and humidity sensors we have digital for local, analog for local, okay, digital for remote sensing. We have temperature switches, right? Sometimes you just want to have a trigger to cut off. It's like a temperature comparator. Okay, once the temperature exceeds, you just trigger. Okay, and then we have isolated temperature sensing. And we also have one thing a lot of people don't know. TI, we sell thermistor. Okay, people think that TI don't sell thermistor, right? If you want to buy a NTC, you don't look for TI. Okay, but if you want to buy a PTC, okay, you can look for TI. We have PTCs. Okay, because PTCs are more accurate. These are some things that TI has some value to bring. Right? And NTC is cheaper and non-linear. So that one, TI not yet involved in that business, but we do linear PTC. Okay. And the next big area is humidity sensor. Now, most of you will not think of TI for humidity sensor. Okay, but we have been having this whole series of products for very long. Okay, so we have digital humidity sensor and analog humidity sensor. And humidity is a very troublesome thing to measure. Right? If you want to measure moisture, but yet you don't want it to get wet. So you have to have a lot of packaging technology to enable all this. So in terms of the packaging technology, right, we give you the various options. Okay, here we have the open cavity. Okay, you can see in the package there's a hole in the middle. That's where you can get your air to flow through, and then you measure the humidity of the air that goes in through the cavity. And of course, with that, the dust can also go in. Okay, dust can go in, and water can go in. Yeah, interestingly, right, you want to measure humidity, but you don't want water to go in, right? But in this case, the water can go in, and when the water touches the sensor, the water evaporates, it dries up, it left some residue that may affect your reading. Okay, so this is one option that we have for open cavity. So to overcome all those other problems that, in case your system gets wet and so forth, we have the removable tape solution. Okay, to help you through your manufacturing process. After you go through your PCB reflow, everything else, you can peel off the tape if you want to. Then you peel off the tape, and then at least your sensor remains perfect condition on the day 1 of deployment. Then there's another category, the HDC 3022 with the IP67 filter membrane. This is the case where, yeah, your equipment, your sensor might get wet. There'll be water on the surface. But then when the water rolls off the surface, it will go back to normal operation. Okay, so we have a special membrane over there to let the moisture in, but not let the water get in entirely. Okay, so we can also filter away the dust and the particles. All right, and other than having the digital sensors, we have the analog sensor, which is the HDC 3120. So it's open cavity, but it gives an analog output. Then you connect to your other circuitry for ADC and so forth to measure. All right, so they are coming in the 2.5 by 2.5 mm WSON. Okay, in case you don't know, the competitor is actually Sensirion SHT3 series, listed over here. Yeah, that's the one that we are pin to pin with. Okay, as I mentioned, we all learn to be pin to pin with our competitors. Okay, so that we all win together. Otherwise, when there's shortage, you all get worried, right? So we pin to pin with our competitor. You have two choices to buy. Okay. Okay. Wow, moving quite fast. Coming on, the last part is position sensing. Okay. Now, position sensing is mainly magnetic sensing as the main one, but we have also other technologies. So in terms of the magnetic one, the switches, latches, Hall sensors, is very good for just to do the on and off detection. Okay, so whether the magnet is there or magnet is not there. Or if you want to do tamper protection, that means someone open your case, you detect that, oh, the case is being opened. So you put a magnet there to detect the magnetic open, close. We also have multi-axis and angle sensors. So you can measure how close is the object, the magnet, to your sensor. Okay, you can select the part number by the axis you want, x-axis, y-axis, or diagonal, and so on. Okay, so we have a lot of different options for the 3D axis options, okay, to measure the angle as well as the strength of the magnet. So you can get a linear reading. Okay, then we also have a linear Hall sensor. It will give you a digital output from the magnetic field. Then you can connect to ADC and do your own readings. Okay, and one other way to detect so-called materials or metals is inductive sensing. Now this one is using a magnetic field, okay, a dynamic magnetic field to detect a metal. So this is good for very advanced applications, such as you want to detect whether this coin is real or fake, right? You can detect the material composition, how many percent copper, how many percent aluminium, through this inductive sensing. Okay, so it's an inductive AFE for very advanced material detection of the magnetic material composition. So it's not just on and off, not just linear, but to detect the differences in the materials. Okay, and other than these four main categories, below we have ultrasonic sensors. Okay, we have a TDC series to do ultrasonic front end. We also have our capacitive analog front end to do capacitor sensing. Okay, so sometimes people use it in some water detection, or they use it for some surface. I mean, it's an object detection for capacitor changes. Okay, for example, there are some products where you walk near to the screen, it will light up by itself. Okay, it's by sensing the capacitance of the human body going near to the object. Okay, so a lot of position sensors solution from TI. And if you cannot remember which one to use, okay, remember this one, okay, the main one here, which is, it's only 6.6 cents. That's how cheap we can make a position sensor. Okay, a Hall effect magnetic switch. Okay, but you want all the other options such as low voltage or high voltage, switches, latches, unipolar or bipolar or omnipolar devices. We have a full selection for you. Okay, and if you see a car over there, it means automotive grade. Okay, so we have an option for automotive grade as well. So TI, we have a large variety of analog Hall effect switches and latches for your various applications. Okay, but the most simple one, the most common one is the TMAG, okay, TI magnetic sensor 5231, okay, which comes to, we operate at 5 volts, up to 5 volts. You have various settings to choose from. The millitesla is the magnetic threshold levels that you can configure. You buy by the ordering of the part number. You can select which one level you want. Okay, and then come in the stock 23 package, X2 zone, and full industrial temperature range, -40 to 125. Okay, so you don't know where to start with the TMAC 5231. Okay, next one, a bit more expensive, linear Hall effect sensor, because it's no longer a switch, right? It gives you a linear reading. So we have analog, digital, single axis, multi-axis, okay, low voltage, high voltage. Same thing, if you don't know which one to start from the price. Okay, 23 cents. TMAC 5253. Okay, from 23 cents, you can get a linear Hall effect sensor that converts your magnetic sensor into an electrical waveform. Then you can do your ADC to do the readings. All right? Okay, so with that, yeah, I think I'm pretty much done with my overview of TI sensor products. So just remember, TI, we have sensor, current sensor, okay, position sensor, temperature and humidity sensor. Okay, so we have all these kind of sensors. So when you want to buy sensor, don't just think of other companies, but think of TI. Okay, it's not totally new. Okay, TI, this one we have been investing for almost 10 years already, and our portfolio keeps getting wider and wider. All right, and we can see that we're not just trying to follow the industry. We are actually doing a lot of innovative breakthroughs with our own technologies, so that we can enable you to build in sensors that are higher performance, lower cost, higher integration. All right. Okay, so that's it for my presentation on the sensors. Any questions you guys have for me? And keep to this page. Yeah. Any questions about sensors from TI? Yes.
Is in TI there is motor with Hall sensor integrated?
Motor?
Motor with motor driver and Hall sensor integrated?
Yeah, motor drivers, we have shunt sensor, right? Motor driver with shunt, integrated shunt.
Oh,
we have motor drivers. Yeah.
Okay.
So motor driver with integrated shunt resistor, we have. Plus also we have, there's two technologies that we have. First is the motor driver by itself, then external shunt. We have motor driver with small shunt. Because motor driver, usually you need a very big shunt, right? So we have an amplifier, internal amplifier to make the shunt smaller. Or we have another series which is totally no shunt. We integrate the shunt into our device.
Yeah. Okay.
So we have three options for you to choose one for motor drivers. But that will be a motor driver topic separately. Okay. So you can email me, let me know what design you're looking for. I can tell you which part to use.
Okay, thank you.
It'll be our DRV8 series. Yeah, DRV8. Yeah. DRV8. Yeah. Okay. All right. Yep. Any other questions you have? Yeah. With motor driver with current sensors. Yeah. Any other questions about sensor? Nobody use sensor from TI? Please start using sensors from TI, all right? Okay, so if no other questions, I'll hand over the time to John to take over for the last session, which is on the electric motorcycles.